Right, now to use the method of elimination, a slightly difficult approach, right? But it's also useful in certain scenarios, so therefore we have to learn it. In this method, we multiply one of the two equations by a constant so that one of the variables in both the equations have the same coefficient. Right, in this approach, we multiply one of the two equations by a constant so that one of the variables, so either x or the y, in both of the equations have the same coefficient. Now, sometimes you may need to multiply both the equations by a constant so that you can get the one of the variables having the same coefficient in both of the equations. But in most cases, you just need to multiply one. So what do I mean? If I can make this y have a coefficient of 5, and then I can subtract both these equations or add both these equations, then I'll be able to eliminate one of that variables. And again, what's the aim? The aim is ultimately to get the equations written in a form that we have only one variable so that we can solve. Right, so watch here. Let's look at the first one. Right, I'll come back to these rules here, right? Same sign, subtract, different sign, add. I'll come back to that rule. So let's look at equation 1. Let's multiply equation 1 by 5. We are not changing the question, we are re-expressing it so that it will enable us to simplify. So therefore, if I multiply equation 1 by 5, 5 times 5 is 25x minus 5 times 1 is 5y, and 16 times 5 is 80. So what we did here was we said 5 into 5x minus y is equal to 5 times 16. And eventually, if I cancel that both, we're just re-expressing. So 5 times 5 is 25x minus 5y is equal to 80. Very simple. Right. So that's what we have here. So I call that equation 3. Now, if you look at this equation 3 and you look at equation 2. Now, remember, you can't look at equation 1 because that's already re-expressed. So let's look at these two equations. If I take this equation and I take that equation and I subtract them, what's going to happen is that the 5y and the 5y is going to cancel. So we'll only have the x and the 9 and the 80. And then we'll be able to solve because we'll have one variable and constants. So we will be able to solve that. This is why I said once you have one of the variables in both equations having the same coefficient, please pause that and hear what I said slowly. Once you have one of the variables in both of the equations having the same coefficient, then you follow this rule. Same sign, subtract, different sign, add. Then you check, do they have the same signs? If they do, then subtract both the equations. If they have different signs, then add what? See, minus 5 minus minus 5 will equal to 0. This is why when they have the same signs, subtract so that you can eliminate that one variable. But if they have different signs, so plus 5, and if they had minus 5, then you must add so that you can get it to 0. So same sign, subtract, SSS, different sign, add. Right, so that's what our aim is to do. So let's do that. And this is very important. How you say it is very important. If you say subtract equation 3 from equation 2, subtract equation 3 from equation 2. If I subtract 2 from 3, then it'll be 3 minus 2. Understood? If I subtract 3 from 2, then it'll be 2 minus 3. This is why you have to be very careful with how you say this. So if we subtract equation 3 from 2, it'll be equation 2 minus equation 3. So this is what I'll do. I'll say equation 2. Let's do the left-hand side first. So it'll be left-hand side minus this left-hand side, right-hand side minus this right-hand side. So it'll be 4x minus 5y, equation 2 minus equation 3. Very important. You're taking this portion from that. Let me repeat that. You're taking that from that. And then it'll be equation 2 minus equation 3. Left-hand side minus left-hand side, right-hand side minus right-hand side. 9 minus 80. And therefore, you're left with 4x minus 5y minus 25x. I'm following S and V plus 5y is equal to minus 71. What's going to happen? And why did we do everything intentionally? So that we can get rid of all of this here. And now we're left with minus 21x is equal to minus 71. Therefore, x is equal to 71 over 21. Very, very simple. Now that you have this answer here, you can take it and substitute it in either equation 1, equation 2, or equation 3. Now, it's very important that, like I said, sit back, look at what you have and what would be the best way to solve it. If you look at this equation 3 and equation 1, obviously I won't use equation 3 because I've multiplied by some number. So I'm basically adding more work, right? Because I need to simplify it. I want to look at this equation that's the simplest to work with. So if I look at equation 1 and equation 2, I will work with equation 1 because y has a coefficient of 1. So by just adding by y on both sides and subtracting by 16 on both sides, I'll be able to have y, or make y the subject of the formula. So I can get directly to y without dividing by something. See here, if I have to solve for y using this equation, I eventually have to divide by minus 5 in order to get y by its own, in order to isolate the y. So that's why I strategically chose number 1, so it's much more quicker to solve. So therefore y is equal to, right, I added by 1 on both sides, so y is equal to 5x minus 16. That's basically what we have for equation 1. And so therefore if you solve this, you get 19 over 21, right? And I've already proved this to you. If you use the method of substitution, then we in fact get the same answer. Two different approaches, you yield the same answer, right? So you can choose whatever you find more convenient to use, and you can choose whatever you find more convenient to use. But this is the basic idea of elimination, right? You can write that down as a rule. We're trying to get one of the variables, either the x's or the y's, in both of the equation to have the same coefficient, minus 5 and minus 5, so that when you either subtract them or add them, you can eliminate that variable. That's what's called elimination. And then you'll have an equation with only one variable in it, and then you can solve, right? And whether you subtract or add it will be dependent on the sign of the coefficient. If it's the same sign, you'll subtract, as I proved to you before, and if there's different signs, you'll add, exactly as I proved to you before. So it's a very simple idea, right? Remember, as I said, sometimes you need to multiply both equations by something in order to get the variables to be the same, right? So let's do a more complicated one, right? Let's take this exact same example. Let's say we want to make x the variable that have the same coefficient in both the equations. So how would I do that? It is very similar to saying, let's find the LCM between both those numbers. So if you find the LCM between 4 and 5, I can tell you it's 20, but if I have to solve it, it'll be 2 times 2, and 5 can only be 5. So take all shared and multiply it by the unshared factors. So you'll have 2 times 2 times 5, because it's all unshared and there's no shared factors. So therefore we'll have 20. Since I have the LCM as 20 for equation 1, I'll say 20 divided by 5 is what? 4. So I'll multiply this equation by 4. And I'll say 20 divided by 4 is what? 5. I'll multiply this equation by 5. Because when I multiply this equation by 4 and I multiply this equation by 5, I can make the variable x have 20 as a coefficient in both equation 1 and equation 2. Right, can you see how we're starting to link the topic? So let's do that. You'll have 20x minus 4y is equal to 16 times 4 is 64. Right? And if you look at equation 2, 4 times 5 is 20x. 5 times 5 is minus 25y is equal to 9 times 5 is 45. And then now, because both these variables have the same sign, so I'll subtract. So I'll subtract equation. Now you'll call this 3 and you'll call this equation 4, because we have to re-express both equations. Right? So that's why we have to give them new names, basically. So therefore, if I subtract both this, I'll have 20. So let's say subtract equation 4 from equation 3. So very important how you write it. So you have to subtract this from that. So you write the equation 3 first. So 20x minus 4y minus, put in your brackets, right? Put in your brackets, it'll be 20x minus 25y. So left hand side minus left hand side. And now it'll be right hand side minus right hand side. 64 minus 45. That'll be 64 minus 45. So now if you have to distribute, you'll have 20x minus 4y minus 20x plus 25y is equal to 60 minus 45. 64 minus 45 is 19. And therefore now if you have to solve, can you see the 20 and the 20 will cancel here? So you're left with 21y is equal to 19. Now y is equal to 19 over 21. And see, when you made the coefficients of the variable x the same, you're basically eliminating the x. So what are you going to solve for? You're going to first solve for y. When you made the coefficients of the variable y the same, when you eliminate that variable, what do you solve for first? X. So that it's just the same thing, we're just doing it slightly different, right? So that's how we get to the answer, by making the by just changing which variable has the same coefficient. Now, obviously, if they tell you, let's say they say, solve this question using the process of elimination, preferably now you would want to make y, the coefficient of y, the same, because then you only have to multiply one equation by 5 by some constant in order to make them the same. Understood? So that's why you have to be very strategic with what question you choose. See, here now you have to find the LCM. If you do it by inspection, it's quick, right? It's quite fast. But I'm saying if you have problems with finding the LCM mentally, then you have to do the entire process as I did quickly here, and get the LCM, and then find out what constant you're going to multiply equation 1 by and what constant you're going to multiply equation 2 by, so that you can make the coefficients the same. Very lengthy process. So that's the reason why be very strategic with what variable you choose. Right.